Amplitude modulation. Here in this presentation we are going to learn what is amplitude modulation and what are its effects. Introduction. A continuous wave goes on continuously without any interval, and it is baseband message signal which contains the information. This wave has to be modulated. According to the standard definition, the amplitude of the carrier signal varies in accordance with the instantaneous amplitude of the modulating signal, which means the amplitude of the carrier signal contains no information varies as per the amplitude of the signal containing information at each instant. This can be very well explained by the following figures. On the first figure, we have seen the amplitude with the baseband signal. The second, we have the carrier signal, and the third is a modulated wave. Following are the mathematical expressions for these waves. Number 1. Time domain representation of the wave. At first, we are considering the modulating signal to be m of t, which is equal to am cos 2 pi fm, and the carrier signal will be ct, where am and a car are the amplitude of the modulating signal and the carrier signal respectively. Next, we consider fm and f car. They are known as the frequency of the modulating signal and the carrier signal respectively. Then this equation of the amplitude modulated wave will be st, which is ac plus am cos twice pi fmt by cos twice pi fct. A carrier wave, after being modulated, if the modulated level is calculated, then such an atom is called as modulation index or modulation depth. It states the level of modulation that the carrier wave undergoes. Now, rearranging the equation 1 as below, we get st, which is equal to ac 1 plus am ac cos twice by fmt cos twice by fct. St equal to ac 1 plus u naught cos twice by fmt cos twice by fct. We consider this as equation 2, where nu is the modulation index and it is equal to the ratio of am and ac. Mathematically, we can write it as nu naught equal to am into ac. Let us consider this as equation number 3. Let am max and a minimum be the maximum and the minimum amplitudes of the modulated wave. We will get the maximum amplitude of the modulated wave as 1. Now, A max equal to AC plus AM, which is equation number 4. Now, we will get the minimum amplitude of the modulated wave when cos twice by FMT equal to minus 1. So, A minimum equal to AC minus AM, which is considered as equation number 5. Now, add equation 4 and equation 5 and we'll get A max plus A minimum equal to AC plus AM plus AC minus AM, which is equal to 2AC, implies AC equal to A max plus twice of A minimum, which is equation number 6. Now, subtracting the equation 5 from equation 4, we get A max minus A minimum equal to AC minus AM minus AC minus AM equal to twice AM, which is equal to a modulated signal will be A max equal to twice of AM, equation number 7. Now, the ratio of equation 7 and equation 6 will also be as follows. Now, after that, we get nu equal to A max equal to A minimum, A max plus A minimum, which is considered as equation number 8. Bandwidth, BW, is the difference between the highest and the lowest level of frequencies. Mathematically, we can write it as bandwidth, which is equal to F maximum minus F minimum. Now, let us consider the following equation of amplitude modulated wave. St, which is equal to AC 1 plus nu cos twice by FMT into cos twice by FCT, which can be rearranged into the following equations. Now, hence, we can see that the amplitude modulated wave has 3 frequencies. Those are carrier frequency Fc, upper sideband frequency Fc plus FM, and lower side frequency Fc minus FM. So, finally, we can get F maximum equal to Fc plus Fm, F minimum equal to Fc minus Fm, and upon substitution of F max and F minimum values in bandwidth formula, we get bandwidth equal to Fc plus Fm minus Fc minus Fm, which can be together compiled as BW, bandwidth equal to twice Fm. Power. Now considering the following equation of the amplitude modulated wave St, now we can see that the power of the amplitude modulated wave is equal to the sum of powers of carrier, upper sideband and lower sideband frequency components. Therefore, power and total power equals to PC plus PUSB plus PLSB. We know that the standard formula for power of cos signal is P equal to Vrms twice R, which is equal to Vm by 2 root over 2 root 2, where Vrms is the RMS value of the cos signal and Vm is the peak value of the cos signal. Carrier power, which is equal to PC AC by root over 2 whole square divided by R, equal to AC square by twice R. Upper sideband power PUSB, which is equal to the following equation, and similarly we'll get the lower sideband power as same of the upper sideband power. Now PLSB, which is equal to AC square nu naught square divided by 8R. Now add these three powers in order to get the power of the AM wave. Hence finally the power of the AM wave equal to PT, which is equal to PC by 1 plus nu naught square by 2.